Hi to all, welcome to Algotech programming concept. We can do analysis of any algorithm in three cases. We can perform analysis of algorithm in best case and in worst case or in average case. So let's discuss the analysis of quickshot algorithm. So we can analyze the quickshot in best case, worst case and average case. So the best case of quickshot will be when elements are unsorted, or if pivot element is found at middle index or near to middle index, then it is the best case of quickshot algorithm. And these are the unsorted elements, and the recurrence equation for best case of quickshot is T of n is equal to 2tn by 2 plus n, because our elements n elements are divided in two parts, the left part and right part. Half elements for left part and half of the elements are in the right part. If pivot element is found at the middle index, so it is the best case for quickshot, and the complexity will be n log n base 2. And we can denote the complexity in any asymptotic notation, whether in big OH, or we can use theta also. So just it's a asymptotic notation. And the worst case of quickshot will be when the elements are sorted. So every time our pivot element will be the last index, or pivot element will be at the first index for the sorted data. If elements are sorted and pivot element is found at the last index, at or pivot element is found at the first index. And the recurrence relation for worst case time complexity analysis of quickshot is T of n is equal to T of n minus 1 plus n. So every time the if we are finding the pivot element at last, then n minus 1 element will be rest element to perform the analysis in worst case. So here the complexity of is order of n square for quickshot in worst case, and we can improve this worst case complexity by introducing the randomized quickshot, where the randomized quickshot produces order of n log n base 2 in worst case analysis. And average case is that when the elements are in mixed type, or elements are means jumbled or not proper ascending or descending order, and here the time complexity will be order of n log n base 2. And further we can do analysis of insertion sort in three cases: best case, worst case and average case. So best case for insertion sort is when elements are sorted. So when elements are sorted means there is only one comparison at each iteration. So this is the recurrence relation Tn minus 1 plus 1, because one comparison is made at each iteration in case of elements are sorted. So this is the best case of insertion sort, and the worst case for insertion sort is that if elements are unsorted. So you can see here unsorted elements, and the recurrence relation will be Tn minus 1 plus n. So the time complexity will be the big O of n square, and the average case is that when the elements are unsorted, so the time complexity will be order of n square in average case of insertion sort. Now third, I am discussing the best case, average case and worst case for linear search. So the best case for linear search is when we found the element, or we search any key and we found at first index, so it will take constant time. This will be the best case for linear search. And what will the average case? When we found the element at mid position or mid index, so the time complexity will be order of n by 2. So we will ignore the half, we will ignore 1 by 2, and thus it produces the linear time complexity at average case of linear search. And the worst case is that we are traversing from index 0 to last index, and element is found at the last index, or one or two position before the last index. So here and this will be the worst case of linear search, and time complexity will be order of n, means linear. And for binary search is faster, and the recurrence is t of n by 2 plus 1, because when we perform binary search, then array is divided in two parts, left part and right part. But we have to choose only one part. Either search will take place in left part or search will take place in right part. Further, right place will be divided in two parts. So what will be the best case if we found the searching element at the center, because we found mid element in binary search, and if element is found at center after first iteration, so it will be the best case of binary search. And the average case will be that if we found the element after first iteration. So here our recurrence t will be like tn is equal to tn by 2 plus 1. Then again we will get n by 4, then n by 8, so and so on. If we solve this equation, then we get order of log n base 2 for average case of binary search. And what is the worst case? In worst case, when we found our element at the last means at last single element, when the search space is divided and we get last single element, and that will be our search element. So it will be the worst case scenario of binary search, and the time complexity will be order of log n base 2, means logarithmic. So we can perform the analysis of any algorithm in three cases: best case, average case, and worst case. So it depends on the algorithm that what will be the best case and average case and worst case. Thanks for watching.